everybody. Welcome to our next week. Couple of things. First, we've made this week just a little bit easier as much as we can because we want to give a few folks the opportunity to get caught up on things. So this is the kind of week that's not going to take you full 5 days to do everything. So take advantage of that and make sure that you're all caught up with everything. So by the beginning of next week, we are all ready to go with day one. All right, so we're talking about the scientific revolution today. So if we think back what we've talked about so far, our big thing that we've talked about is the Renaissance and then the Reformation. And one of the things that these guys have in common is this idea of questioning. So during the Renaissance, people are beginning to question, is everything related to the church? Can art be more than just religious? What is man? What is important to us? What should we study? Is our focus, should it be just this life or should it be heaven and those kind of things? Then we move to the Reformation and we kind of move beyond art and those kind of simple things. And it starts this idea of humanism and questioning to the Reformation where we're actually questioning the church. Now, this concept of humans questioning, which is something that we do today, it's part of our human nature. It's important to remember that this course really starts the modern world. Like the things that we think of, we study and do in school, it really is because of what happened during the Renaissance, Reformation, all those things. So this idea of questioning is very important and it's going to follow us for the next couple of units. So now we're questioning not just the church, but now we're starting to question science. And the church is going to feel very offended by this because by questioning science, the church is going to feel that you're questioning them. Okay, so that's kind of an important thing to kind of keep in mind. Things that we take for granted today were not common knowledge at that point. All right, so you have a note sheet that has been given to you. And on this note sheet, you're going to be highlighting and answering questions, okay? I'm going to provide a copy of this answer sheet as a little supplemental material after the video that you then can make sure you've got everything filled in and added in correctly, all right? So there's a couple of questions on your worksheet that you'll kind of answer. So before the scientific revolution, knowledge was based on superstition and belief. So they believe things because that is what the church had always taught them. In our society, church and education and science are all kind of very separate. But back then, the church controlled everything. They controlled government. They controlled education. And so things are just now starting to change in this time that we're studying. And we kind of take these things for granted today. So it's important to understand that the way we think today wasn't always the way things were. So if the church told you that's what it was, you believed it. And also keep in mind, most people couldn't read up until people are now beginning at this time period starting to get educated. And so that's part of the problem too. If you disagreed with the Catholic Church, what was that called? Remember, that was heresy. You were considered to be a heretic. And what happened to heretics? They got excommunicated, excuse me, and then they would get kicked out of the church. And that was a big deal because it meant you lost your church membership. It could be as extreme that you actually get burned at the stake, say like John Hus did. But being excommunicated and losing your church membership meant that you couldn't go to heaven. And so this is why this is such a big issue. So when we think about this, as people are trying to learn new things, how might this affect them? If you question the church, you're going to lose your membership. So then how likely are people to question the church? People are in fear and they're not likely to question the church. Remember that the Inquisition, which is in response to the Protestant Reformation, they're putting people on trial for speaking against the church. And some people were tortured. Some people were killed. I mean, think about Bloody Mary. She killed 300 Protestants just because they didn't agree with her. Okay. And so it is important to understand that there is a bit of fear if you speak out or try to learn something new. So for example, this time period, people believed that the earth was the center of the universe, meaning that we're at the center and that the sun and everything moved around us. Now, we know now that that's not true, but that's what people believed. And this was called the Geocentric Theory, meaning that the earth was the center of the universe. And this was the Ptolemaic theory that had been taught since the time of the Greeks. Okay. And so people just pretty much, that's what they kind of understood. Now, Nicholas Copernicus, he was a Polish scientist and he did a lot of studying and he began to realize that the sun was actually the center of the universe and that the planets orbit and move around that, meaning that we on the earth, that we move around the sun. This is called a heliocentric universe because remember, helio is sun, geo is earth. So he now has this new theory. He writes a book, but it's not published till he dies. Like, he keeps it to himself because he knows if he goes out and tells everybody that he's going to get in trouble. So again, why does he want to keep it to himself? Because he doesn't want to get excommunicated. He doesn't want to get in trouble. But after he dies, people began to see his teachings. So Copernicus is using different. He's not just basing it on superstition and belief and what the church has taught, but he's using logic and reason. And so reason, using this idea of logic and reason, is going to change. It's a huge change in thinking. So before the scientific revolution, thinking is based on superstition and belief, just what the church told me. And then it becomes, after the scientific revolution, based on logic and reason. So think about, when have you used logic and reason? Like, you step outside and it's raining, you go back inside and get a jacket or umbrella. That's logic and reason. I don't want to get wet, so I use an umbrella. Okay. If you are sick, we're hold the whole thing, like, why are we wearing masks? Why are we washing our hands? During the bubonic plague, the church taught you that if you washed too often, you would actually catch the bubonic plague. And so if you cleaned yourself too much, you would get sick. Now, that's what the church told them. That was superstition and belief. But logic and reason now teaches, and we know about germs, right? We know that we do have to wash our hands and stay clean. The scientific method also develops during this time period by Sir Francis Bacon. And so it's the idea that we're using measurement and reason, and we're doing observations, and then we're coming up with a hypothesis, and then we're repeating that to make sure that our conclusions are true. So again, this is one of your questions on your sheet. Before the scientific revolution, knowledge is based on superstition and belief. During the scientific revolution and after, it's based on logic and reason. And which do you think is better and why? One of the things I always tell my students is I kind of like a little bit of both. So I'm a religious person, and so I believe in God. There are things that I can argue, that I can see in logic and reason, that someone created this, but that's something that I just have to take on faith. And so that's my belief part. But then I use logic and reason all the time in everything I do. So maybe there is a bit of a happy medium. So you can think for yourself, which one you think is better. So let's talk about our people. So I've mentioned Copernicus already. He's important. Now, what I will show you on my sheet that I did is I actually draw a picture for each of these to help me remember. So I think the sun for Copernicus. So later when you see my sheet, you can laugh at my drawings. They're a little sad, but I try, okay? So I think the sun, because Copernicus came up with the heliocentric universe. So Francis Bacon, so he's knighted later for his work. He's from England, and he came up with the scientific method, and it really changed the way that people thought, and so when I think the scientific method, like I think like a little beaker in science class, and how, we do that, and we think about that. We've got to, it's that whole thing. It's a step. So how I remember this is I literally think bacon. I like bacon, but it's a step process, right? I got to cook bacon so that I can put it in my mouth and have the yumminess from a BLT or just some bacon. And so that step process, I think about the scientific method. So Copernicus is first in your notes. And so Copernicus, of course, is from Poland, and he's the one who comes up with the heliocentric theory. But again, he kept his ideas to himself. So I always put a sun. So for each of these guys, you want to highlight their name and their most important things. So we want to highlight Copernicus, and we want to highlight that he did the heliocentric theory. So Kepler actually proves that Copernicus is right. So Kepler is from the Holy Roman Empire, which would be present-day Germany. The joke is always that the Holy Roman Empire was neither holy nor Roman nor an empire, but it covers what's present-day Germany. So Copernicus uses reason and math to prove that Copernicus is right, and he writes a book. Now, the other thing that he discovers, and this is his most important thing you want to kind of underline, is planetary motion. And I'll tell you kind of the way I help remember that is that Kepler has this PL in his name, and so I think PL planets. And so I think about Saturn. So Saturn, has rings on it. Okay. And so I think about that he knew that the planets moved in an elliptical shape, that the planets, it's not a perfect circle, them going around the sun. Instead, it's an elliptical shape. Okay. And elliptical is, like a kind of like an oval, right? And so Kepler proved that Copernicus was correct. But the most important thing is that planetary motion, that planets move in an elliptical shape. Galileo is fascinating to me. So one of the things you do after this is we have 2 brain pops that we want you to watch. The first one is on Copernicus and the second one is on Newton. If you have extra time, if you're in brain pop, if you actually search Galileo, there's one on him too that I think is really interesting, but that's kind of an optional thing. So Galileo is from Italy. And he also proves that Copernicus is right. He works with Kepler's theories. He also develops an improved telescope. Now, he didn't invent the telescope, but he basically figured out a way to do different design, and that's what makes him so important. So you're going to want to highlight the word telescope. And I always draw a telescope. My telescope always looks like really top heavy, like it's going to just fall over. But he invented the telescope. Now, what makes him also really interesting is that he didn't keep any of this secret. He writes a book. And he gets called in. He gets called in and put on trial. Like, he's in Italy, right? Which is hardcore Catholic Church. Remember, Italy and Spain are the 2 strongest. Kepler's maybe a little safer because he's in the Holy Roman Empire. And in Germany, remember that there's a lot of Protestants there. So he's maybe a little safer because of that. Galileo's in Italy, hardcore Catholic. So he gets called in. And they're like, you need to take it back. You need to recant or you're a heretic. So he did take it back because his option was to be excommunicated and exiled, sent away from his home. And, well, he wanted to live in his home. So there is the rumor that when he left, that he famously said, well, you can believe what you want, but I'm right. Basically, even though he publicly said, I'm wrong, he still knew that he was right, that even though the church disagreed with him. So then we have Sir Isaac Newton, who's probably the most famous of our scientific revolution people because he did so many things. So he's from England. He used reason to discover the laws of gravity, the laws of motion. He invented calculus. I mean, this guy is definitely a genius. And so, of course, he doesn't invent gravity, but he discovers and explains the laws of gravity. And very famously, everyone like, oh, yeah, like an apple fell on his head. Well, actually, the story doesn't go quite like that. I'll let you watch the brain pop and get to hear the story. So William Harvey, we have a really fun way for you to remember him. Miss Nash always likes to talk about Carvey Harvey. So does that make you a little interested? What in the world is Carvey Harvey? Now, I may be not as dark because I like to remind my students, I think Harvey and I think heart, okay? So here's what William Harvey did. He actually discovered the circulatory system. So basically, he kind of figured out how blood moves. And in studying the body, there obviously had to be some cutting of the body. So that's how we get Carvey Harvey. So Carvey Harvey founds blood. So think about heart and Harvey and the circulatory system. There's going to be another guy by the name of Vesalius. And he actually writes a book and draws all these things that all these people have been talking about. And it becomes the #1 bestseller of the time. Can you imagine? It's basically an anatomy textbook. It becomes the #1 bestseller because people are so fascinated. They don't know what the human body looks like. And people are doing autopsies and all these things and using logic and reason to really understand stuff. So when I'm doing my little sheet, I put a heart beside Harvey. I put an apple beside Newton. And I try to make it look like an apple, not like a tomato. And I draw a telescope with Galileo. I draw the sun with Copernicus. And I said the heart or a little circulatory system with Harvey. So all of this is using reason and observation to understand everything and come up with a scientific method. Okay, so you're going to now fill out your notes. So you're going to, when you finish the video, you're going to click on the link for the notes, make sure that your notes are filled out like I did. And then you can use your notes to help you do your exit ticket, which is your next activity. And I will see you back for your next lesson when we talk about exploration.